Hello, let's continue our Sudoku adventure with Snowmen by Palfly Kampling. So we have normal 6x6 Sudoku rules, meaning in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these snowmen in the grid. The snowmen are made up of a small circle, a medium circle, and a large circle. Each has its own rule. The small circle is a white Kropki dot, so it separates consecutive digits. So if this was a 2, this would have to be a 1 or a 3. Not all the dots are necessarily given, so if this was 2, 3, those are consecutive. There's no white dot. That's perfectly fine. We're allowed to do that. The medium circle is a quadruple. It's always going to touch whatever cells it touches, and usually 4. This one down here is a quadruple. It touches 2 cells because it's on the edge of the grid. But usually it touches 4 cells. And what this tells us is the digits that appear in the quad have to appear at least once each in the surrounding 4 cells. So we need a 1, 3, and 5 present in somewhere in these 4 cells. If the digit repeats, so we have 2 2s here, that means we need to place 2 2s in these 4 cells. We could do, for example, a 2 here and a 2 here. All right. Now, this doesn't prevent us from having more than one of these digits. We could do like 1 1 here, for example. That would be perfectly fine, as long as everything else works out. The big circle is a Renban circle. So you can kind of think of it as if we had a Renban line like that, if you want, or a loop. But either way, these 4 cells that it touches form a consecutive set of non-repeating digits. So if you took the 4 digits that surround it and you kind of take them as a set, they all form a consecutive sequence. So we could do, for example, 2, 3, 4, 5. The order doesn't matter. What matters is that we haven't repeated any digits, which is true. And if we take them as a set, they are consecutive. So we can't do 2, 3, 4, 6 because now the 6, 2, 3, 4, 6 is not a consecutive sequence. All right. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right, what draws my eye immediately is this 2, 2 here. Because what that's telling us is we need 2 2s. And we're not going to do them in the same column or the same row. So we're going to do it diagonally. We're going to either do 2 2s like this or 2 2s like this. So we can mark 2s like that and that. The immediate obvious thing is that means there's a 2 up here somewhere and a 2 down here somewhere. But I can immediately see that we know there's a 5 on this. We know there's a 5 on this white dot because of the 5 quad. And so we can't put a 2 with the 5. Those aren't consecutive. So we get our first digit. That's a 2. And then with the 5, it's just going to be with a 4 or a 6. So this is from 4, 5, 6. Definitely has the 5. So let's just mark 5s up here. We could do 2, 3, 4, 5. So 2 and 5 can coexist. I was checking that. Let's look at this next, actually. This quad has a 1, 3, and 5 on it, but I will also tell you it has an even digit on it up here, because 2 consecutive digits, which are these 2, across a white dot, 2 consecutive digits, one is even and one is odd. 1, 3, and 5 are all odd digits, so we're going to need an even digit to go up here with the 1, 3, or 5. So that fills up this quad. This quad is going to be 1, 3, 5 with an even up here. So we can actually mark 1, 3, 5 here. These are definitely from 1, 3, 5. We don't know which 2 it is, I don't think. And what's interesting about that is with this 2, we're going to use the other 1, 3. So this 2 needs a 1 or a 3 to go with it. And then this needs to be a 1, 3, or 5. So this definitely has the 5 on it. So up here, what we can say is this is the 1 or 3 with an even that goes with the 1 or 3. That's 2 or 4 only. Nice. Okay, and that means there's a 5 down here, because we know this quad is telling us there's a 5 here, so there can't be a 5 here, and these are pointing in. So there's a 5 down here. So let's think about this then, because we just forced a 5 onto. Oh, we can think about this as well, but anyway, in general, if there's a 5 on a Renban circle, what's the lowest we can get? Well, we can go 5, 4, 3, 2. So 2 is the lowest we can get, which means there is no 1 on this Renban circle. So 1 in this box then goes here. And 1 somewhere down here. And then same thing here. This can't be a 1. Since there's a 5 in this Renban circle, there is no 1 in the Renban circle. And so that then gives us the 3, 5 pair, giving us the 2 and the 1 here. Oh, wow, that did a lot. That places the 2 here. There can be a 5 or a 1, but not both with this 2. Interestingly. That's not a 2. In fact, 3, 5 pair takes 3 out of these. So this is the 1 along with a 2 to go with it. So that's a 2 and that's a 1. It places the 1 down here. Oh, this is good progress. I don't know. Well, there is no 1 in here, so there must be a 5 in here. Because since there's no 1, it's 2, 3, 4, 5, leaving the 6 behind, and this is the only place for 5. 3 and 5. This then is 3, 4 pair. That's a 4, that's a 3. These can't be 4. Right, we get a 3 in the corner, shooting out snow there. This is a 4, 6 pair. This is the 4, this is the 6. These columns can finish. This is a 3. This is a 6. And this is a 4, 5, which we can't resolve yet. I think if I just fill out these rows, especially these ones, I think that'll help. So here we need 3, 4. Yeah, okay, so there's another interesting thing I want to point out about 4-cell Renbans like this, which is there has to be a 3 and a 4 on the Renban. Because if you omit the 3, you also have to omit the 1 and 2, and you end up with only 4, 5, 6. Same thing with 4. If you omit the 4, you're also omitting 5 and 6. Because you can't just do 5, 6, right? And so then you only get 1, 2, 3 on it. That's one way to think about it. Another way to think about it is just go through the options. 1, 2, 3, 4, 2, 3, 4, 5, 3, 4, 5, 6. All have 3 and 4. So this has 3 and 4, but that doesn't tell us the order of these, but there is a 5 on here. So it's either 3, 4, 5, 6, or it's 2, 3, 4, 5. This would, oh, we can't put a 2 at all. So it is 3, 4, 5, 6. Okay. That leaves the 3 for here. That gives us the 5 on this quad. What do we need? 1, 2, 4? That's not 1, that's not 2. 4 would have to go 3. So this is our 4, that's our 2, that's our 1. I think we're just filling this out. These are both odd. In fact, and they can't be 1. Since, okay, why are they both odd? Well, these are both even, and there's 2 evens and 2 odds on every Renban circle. And so this is going to be 3, 5. You know, that's the 5, that's the 3. Giving us 2, 3, 4, 5. That's 4 and 5, that's 4 and 3. That's a 6 and 5, 6 and 5. I think we're just finishing. Where's the 1 go in this box? It goes there. Where's the 2 go? Right there. That dot worked. And then we need 4 and 6. And we're done. All right. That flowed really nicely. Thanks, Palfly. I think I picked the right things to start with. Although there may have been multiple ways to get started on this, but it was interesting that we forced 5 here and 5 here, both on these Renban circles, both eliminating 1. Seemed very important. All right. Cool. Well, very well constructed. I enjoyed that. Let me know how you did. If you enjoyed it, why don't leave a like, subscribe, and a kind comment below.